So there's more than one way you can go about solving this problem. I'm going to show you at least two different ways. Starting with applying the exponent, this exponent here, inside your brackets everywhere. So what I get is 5 to the power of negative 1 divided by x to the power of, it's the power to a power, so I multiply negative 2 with negative 1, that gives me 2. Now, the negative 1 in the numerator, in the exponent of the numerator, means take this number to the denominator. So I have 1 left on top, because there's an imaginary 1 multiplying my 5, which never moves, it stays there. And then the 5 comes down to the bottom to the power of positive 1 times x squared. Another way of looking at this is to, so I'm going to rewrite it over here, 5 over x to the power of minus 2, all of which is to the power of minus 1. Another way of looking at this is to say, okay, well this negative 1 here, my exponent, this negative means take the reciprocal of this fraction in the brackets. So I'm going to rewrite all of this as x to the power of minus 2 over 5 to the power of positive 1. So what happened is I flipped the fraction in the bracket, I took its reciprocal, and I changed the exponent outside the brackets from negative to positive. Now if this were actually if this number here, the positive 1, if it were any other number, like a 2, I would have to then apply it inside my bracket everywhere, but because applying an exponent of 1 to everything inside this bracket doesn't change anything, then I'll ignore that it's there. I'll pretend it's not even there. So I'm going to rewrite this as x to the power of minus 2 over 5. Now this minus 2 over here, this minus 2 tells me, okay, the negative says bring this x into the denominator. So this is equal to, and now there's an imaginary 1 multiplying my x, so I leave the 1 on top. And this is now x squared, because the negative told me to bring this to the denominator, times 5. So let's take a look at the two solutions we got. We got this and we got this. They're identical. So both methods of solving this lead me to the same answer. That's it. You're done at this point. You're done.